హైదరాబాద్ నగరంలో నీటిని సంరక్షణ చేసే ప్రయత్నంలో ఇదొక భాగం మా యొక్క విభాగంలో, మా యొక్క జీవితంలో. అయితే ఇప్పుడు మేము లిటిల్ ఫ్లవర్ డిగ్రీ కాలేజ్, లిటిల్ ఫ్లవర్ జూనియర్ కాలేజ్ ఉప్పల్లో ఉన్నామన్నమాట. ఇక్కడ మేము చేసేది ఏంటో మీకు తెలుపుతాము. మానవలోకానికి స్వాగతం, మా నవలోకానికి స్వాగతము, మా లోకానికి స్వాగతము. మేము ఇక్కడ చేస్తున్నది ఏంటంటే జియోఫిజికల్ అసెస్మెంట్ చేస్తున్నాము. అనగా హైడ్రోజియాలజీ ఎటువంటి పరిస్థితిలో ఉంది, ఎంత లోతులో నీరు ఎలా ఉంది, నీటి మట్టం ఏ లోతులో ఉంది ఏంటి అన్నది చూసి మేము ఈ కాలేజీలో నీటి సంరక్షణ ఏ విధంగా పరిచచ్చు అని చెప్పి ప్రయత్నాలన్నీ చేస్తున్నాం. సర్వే చేయడమే కాకుండా మనకి ఇక్కడ ఈ అధికారులు, లిటిల్ ఫ్లవర్ కాలేజ్ అధికారులు మాకు ఇక్కడ నీటి సంరక్షణ చేయగలిగే యొక్క ఇంప్లిమెంటేషను, తర్వాత ఆ కార్యాచరణ అంతా చేసే అవకాశం కూడా మాకు వాళ్ళు ఎంతో సహృదయంగాను మనవపూర్వకంగాను మాకు కల్పించారు. దాన్ని ఇప్పుడు మనం ఏ విధంగా దీనిలో వెళ్తామో ఏంటో అన్నది చూస్తాము. ఇది ఒక చిన్న కాలేజ్, పెద్ద కాలేజ్. మా యొక్క ఎన్నో విభాగాల్లో ఎన్నో కాలేజీల్లోకి ఇది ఒక మంచి కాలేజ్ అనమాట. ఇక్కడ మేము ఎంచుకుని మేము చేయబోతున్న పనుల గురించి తెలుసుకుందాం రండి. చూసారు కదా, మనకి దీనిలో ఇన్స్ట్రక్షన్ మాన్యువల్, తర్వాత బిల్తో పాటు రకరకాల యాక్సెసరీస్ వచ్చి ఉన్నాయి. దాన్ని మనం ఒక్కొక్కటి ఏమేమి ఉంటాయో చూద్దాము. ఇది మనము WTS జియోఫిజికల్ అసెస్మెంట్, జియోఫిజికల్ సొల్యూషన్స్ అనే ఒక కంపెనీ, చెన్నై కంపెనీ అనమాట. వాళ్ళ ద్వారా మనం కొనుగోలు చేశాము. ఆ అధికారులు కూడా మన దగ్గరికి ఇక్కడ వచ్చి ఉన్నారు. వాళ్ళు డెమో తర్వాత ఏమో మనకి ఇది ఎలా వాడాలో కూడా మనకి నేర్పించే ప్రయత్నం గల వాళ్ళు చెన్నై నుంచి బయలుదేరి విచ్చేసి ఉన్నారనమాట. దాన్ని వాళ్ళ మాటలతోనే విందాము.
Very good morning to everybody. So I'm happy to be present in this location in a Little Flower Junior College Uppal, and very much thanks to Vasan for providing this opportunity to supply this equipment and give a demonstration and training in this campus. So today we will see this geophysical groundwater high precision groundwater detector magnetotelluric equipment. So basically it is an audio magnetotelluric equipment. This is the mainframe. So this model is 500AX. So this equipment has the capacity to go up to 500 meter deep from shallow level to medium and deeper level. So shallow level it can go up to 60 meters and then 100 and 200. In medium deep 300 and 400, and deeper section it can go up to 500 meters deep. So this is the mainframe. So this mainframe has a switch and a monitor, and then it has a rechargeable port, and then this socket is for connecting to cable and then as well as the sensor. So this is about the equipment. So in this equipment you can power on, and then you can give the input how much depth you are going to find, and then you can start the survey with either sensor or electrode. So and once it is done, instantaneously we can get the graph with the 2-dimensional section. The graph will come in with the x and y coordinates. It's a 2-dimensional graph. So the graph in the graph itself it will give an indication of the water bearing zone. So it is more helpful. And one more most advantage of this audio magnetotelluric equipment is that it can it can go for more deep in the place with the space constraints. Like earlier we are for groundwater investigation they are using the geoelectrical resistivity method. In resistivity method you need large space go for the deeper investigation. For example, if you want to go for 100 meter deep, you need at least 200 meters or 300 meters. The depth of penetration it depends on the electrode array, terrain condition and the electrode spacing. So you have to go for deeper. You need more large space. But using this audio magnetotelluric equipment you can use this equipment in the place with the space constraints, like even 5 meter or 10 meter or 20 meter space is there. So linear space is there. You can go for deeper investigation up to 500 meters, 800 meter and 1200 meter also. But this equipment is confined up to 500 meter deep. So this is what about the brief introduction of this equipment. So let us see the spares. So the major thing is that it works with the cable. So this cable is 10 meter long. The cable is quite rugged and sturdy, and it is connected with the steel connector with 7 pins. So and it has 2 sockets. This is M port and N port, which can connect with the electrodes. So we will show we are given this hammer also. So two hammers for the grounding the electrodes, and these are the electrodes. So electrodes can be directly clubbed in this socket. So there are sockets are given, and then you can screw this socket also. Hold it. So you can screw the socket and you can tighten it. So two electrodes are used. So they are kept 10 meter apart, and in the midpoint you will get the data acquisition. So data acquisition is directly transferred to the equipment, and in that equipment you can process data and you can retrieve the final graph. And once it is done, you can transfer to your Android mobile or tablet, and you can visualize, or you can use it further processing. You can use the Surfer software as well. And then this is sensor. So this is we can call it as a electrode sensor adapter, or we can call it as C1 sensor generally. So this sensor is also having 7 male pins, and it can directly pair with the equipment and it can work. So generally the electrodes has its own application to work on the natural ground. So natural ground where there is a good soil cover, you can use it because the contact resistance will be low, so you are able to use the electrodes. The places which has the contact resistance is high, so in those places we cannot use the electrodes. We have to use the electromagnetic sensor. So nowadays in urban areas, or if you see in other areas like undulates, like hilly areas, there will be outcrops will be seen. Even in urban area you can see a lot of concrete pavements are there, and then cemented platforms are there, as well as bituminous road or asphalt roads are there. So in those places we cannot drive the electrode. If you drive the electrode, contact will be too high, so you cannot get the data acquisition. So in that place, this electromagnetic sensor will be more useful. Besides this, it can be used in the debris area also, where you can do the data acquisition. So debris area, or you can see in the places with loose sand, wherever the contact resistance will be high, using the electrode in those places, it can be a substitute and it can acquire the data. So loose sand like beach area or banks of the river in sedimentary zone, you can use it. And this is for the data transfer. So this is a USB cable. So from the equipments, once the work is done, you can go to your lab or office and you can transfer the data to your system, PC, and then you can do the post processing and report making. And it comes with inbuilt battery, so it can be charged also. So this charges is provided. So this is the brief introduction about the equipment. So the first and foremost thing is that we have to spread the cable for 10 meters. We have to spread the cable. So in order to measure it, we are placing the measuring tab. So in the measuring tab, it is spread for 10 meters now. So you can see there are two takeouts. This is M and the other one is N. There are two takeouts are there. So we are going to drive the electrodes into the ground. So both of them are 10 meters apart now. So each takeout. అక్కడ కొట్టండి 10 meters. So now M and N electrode, both the electrodes are now being grounded. So now we are grounding the electrodes. Once the grounding is done, now you can see in the equipment there is a red color pointer is there in the equipment socket, female socket. So in the cable also we can find this kind of red color pointer. So what you do, you have to fix it together. So you can fix it. Once you fix, you will get a click sound. Once it is done, that means the cable is properly connected to the machine. So now it is ensured that the cable is properly connected. So now what we will do, once it is done, now we will go for a shallow investigation about 60 meters deep. So here it has depth option. As I told, it has 60 meter, 100 meter, 200, 300, 400 and 500. So first we will go for a shallow investigation, which can be useful for the recharge studies. Once it is done, we have to power on. So once you power on, it will take few seconds, nearly 15 seconds it will take to on. Once it is on, you can go here, you can see the monitor. So on the monitor you can find different icons are there. So in that you have to take the prospecting icon. In the prospecting icon, you can see different functions like serial connection, and then derive by touchscreen, file folder, all these things. So you just leave it and just go concentrate on the new measurement. In the new measurement, you can give the file name. So here file name can be given as alpha numerical. So alphabets and numbers can be used. So today we are at Little Flower College. So we so so we can write as L F J J C. So we can write it. So it is a first section. So what we'll write 01. Done. Then any remarks, it is ground. So we are working on the ground, natural ground. So we give on the remark. So once it is done, you go for the confirm. So in the confirm, it is asking you have the provision for the depth measurement 60, 100, 200, 300, 400, 500. So now I am choosing the depth 60, and it is asking whether you are going to use a sensor, magnetic sensor or electrode. So here you can see we are using the electrodes only. So we will choose the electrode. So once the electrode is done, then it is asking how many channels are there. Since being it is a single channel measurement, one measurement takes at a time, so it is a single channel. So we choose the single channel option. Next it is asking the number of it is asking how many superpositions are required. That means it is nothing but staking. So default it is 4. So it will, if once it is measuring, it will take 4 readings. In that, out of 4, best reading is recorded. So if you want more accuracy, you can go for 5, 6 or 7. So it will take the average and the best reading of that, and it will record that in the equipment. So here we will choose 4 default. So then you go for the confirmation. Okay, once it is done, you can see we are choosing 60 electrodes. So here the measurement frequency is at 2 meter. So every 2 meter it is going to record in the subsurface. So you can see in between these 2 electrodes it is 10 meter. So midpoint 5 meter we are going to have the measurement. So the data acquisition happens within the 2 electrodes. So now we are you can see like 60 readings means it is going to 60 at 2 meter interval. That means we are going to acquire 30 reading at the midpoint. So you can press measure. So there are many equipments in the market, but they go with a 10 meter interval and 5 meter interval for shallow level. So you will miss the target zone. So you will miss the aquifer bearing zone. So but here it is at very shallow level. We are going at very closed interval. So this is the best part of major feature of this equipment. Major feature and the major advantage of this equipment. So now you can see the percentage is going on. It's showing 20%, 23%. It is keep on progressing. Data acquisition is progressing. That means the data acquisition when 20% means out of 60 meters it has went to nearly 12 meters. So if you keep on increasing 36 meters. So it consumes times, it acquires the telluric currents in the subsurface. So we are giving very passive current and active current, and we are recording the passive current in the subsurface. So today our senior hydrogeologist here, Mr. Shelva Kumar, who is a consultant of WTS Geophysical Solutions, and so he will, once the data acquisition is done, he will be giving his interpretation about the subsurface formations and then the aquifer bearing zones. Completed. So you can see the data, acquired data is displayed here. So now if you want to confirm, you can confirm it. Or if you find any kind of disturbance has happened, for example, any kind of vehicle, heavy duty vehicle disturbance, or any other kind of disturbance you have encountered, or during measurement any power line is there, you find data is anomaly, then you can go for measure again, or you can change the location also. So that's what it is having, measure again. Or in between the cable got disconnected because of cattle movement, that time also the data may be disturbed. So if you want, you can measure again. So here we didn't find any disturbance, so we are confirming the data. So now it is done. So we are going to profile from south to north direction. Now the first electrode M, which is very close to the machine, is on the southern direction, and the other electrode which is far from us, 10 meter far, that is in the northern direction. Now we are going to do the profiling at 1 meter distance. So our midpoint is going to change, but the electrode separation remain the same. So 10 meter standard distance is going to be maintained, but we are going to change the electrode position. So now we are going to change the electrode position at 1 meter ahead. So now for the first position it is at 0 and 10. So in the second position it will be at 1 and 11. Tap extend to 15 meters. 1 meter. 1 meter. But there also they have to change, no? 11 less stop change. Okay. Correct. So now we are taking the profiling. We are continuing profiling from south to north direction for the third station. Now the same thing. Now electrodes are shifted and grounded properly. Now we go for the measurement. So press the measure button. Okay. Now the accurate data is being displayed in the monitor. Now you can go for the confirmation. So once it is done, so we have completed 3 stations. So now we are going for the 4th station. So now we will shift the electrode 1 meter ahead in the north direction. For the 4th station, electrodes are being grounded properly. Now we go for the measurement. So measurement is progressing. So now 3% completed. Let us wait for at least a minute. So the complete data acquisition will be done for this station. Okay. So now the data acquisition is completed for the 4th station. So now we are going to switch to the 5th station 1 meter ahead. So now we are going for the 5th station. The electrodes are grounded. We are repeating the same. Now we are going for the measure again. It's almost 50% complete for this station. So once it is done, the next one is the last. So minimum 6 readings is required for developing the graph. So 6 stations has to be done. More 6 or more, at least 6. With 5 it will not. 5 or 4 or 3, whatever it is, it will not draw graph. Okay, it is done. We are confirming the data. So now we will switch to the next location. 1 meter ahead. So now the 6th station is being, electrodes are grounded. Now we are going to press the measure again. So data progressing is happening. Measurement is continuing. So for any data acquisition, we need for drawing any graph, we need minimum at least 6 station data points. So if it is less than 6, it will not draw the graph. So at least 6. So more than that, it is good, well and good. 7, 8, 9, 10 or 11, 12, you can develop a graph with broader scale. So x coordinates will increase and depth will remain the same. Now it is almost 63% completed. 18. So it is done. So data acquisition is complete. So once data acquisition is complete, we need not worry, just we remove it. So we can see here. So for this file, okay, so here you can see the file name, that is Little Flower Junior College 01 is the file name is there, which we are given in abbreviated form, short form. So here we have taken the 6 stations. You can see 1, 2, 3, 4, 5, 6. In this you can see 2 meter, 4 meters, 6 meters, like that it has went up to 60 meters. So 6 stations are there. Before this, if you see the draw button or delete draw button will not be active. It will not be in blue color. It will be in gray color only. So once 6 stations are completed, it will turn into blue. That means it is ready for drawing the graph. So now let us go for draw the graph. Let us see what are the options are available. It has classic version. Classic means it will give the default traditional version, and it will give the x-axis, y-axis. New version is there. Graph 1, graph 2 is there, and this is A analysis. For A analysis, you need to connect with Wi-Fi. Then it will show, it will mark the water bearing zone, and it will give you. So now let us go with classic, because we are not connected to the internet now. So we are going with the classic version. So classic version, it has given the graph. So here this is your y-axis and this is your x-axis. The first station is your 5 meters on the measuring tab, and second station is 6 meters on the measuring tab, and third is 7 meters, then so on 8, 9, 10. So you are in the measuring tab from 0 to 15 meters we have spread. So 5 to 10 will be your data acquisition portion. This is your portion, and 0 to 5 and then 10 to 15 is your fringe zone. There is no data zone. So wherever you want to mark which is your target area, so you try to fix it in the center portion, like between 7 to 8 or 7 to 9, so that it will be easy. For example, you have done a resistivity survey in the same location, you want to map it. So what you do that you make the center something falling within 7 and 8 or 7 and 9, so that it will be very clear in this graph. Again, if you want to save this, you can click this memory card symbol, or if you don't want, you can close it. So now I go for save option, so it is saved in this device, and here you can see the values. These values may be a new whole number, or it may be a decimal also. And same thing, if you want to go for 3-dimensional graph, you can press the 3D option. It's not visible because of the daylight. So now, yeah. So 3-dimensional graph, but it is a 3-dimensional graph. But since it is a 3-dimensional graph, but it is an extrapolation of the 2D graph. It is not actual 3D, but it is an extrapolation of 2D graph. So if you want to do 3D graph, you have to repeat the same line 4 or 5 or more sections at equal interval. Then you feed in the software, and you can develop using the surfer. In surfer you feed, and you can develop the block image. So now this also we save, and then we close it. So for this data interpretation, we will continue this session. Thank you. So now we are at the other side of the entrance side of the Little Flower Junior College campus. We are planning to do the groundwater investigation on the cemented platform. So now previous to this, we have done the survey in the natural ground using the electrodes. But using this equipment, it is feasible to find the groundwater on the subsurface of the floor, which is having cemented platform or debris or bituminous or asphalt road. So now it is a good chance, and thanks to Little Flower Junior College and Wasan, Hyderabad, for providing this opportunity. Now let us start the work. So now the same procedure we are following. We are just to switch on the machine, and we are making a file name. So Little Flower Junior College 2, and we are keeping the depth option up to 60 meters. And then after that, we are now we are already connected with the sensor on the same socket where the cable and the electrodes are connected. So cable is connected. The same socket is being used. So what is the major advantage of this sensor, electromagnetic sensor? So wherever the places where the contact resistance will be high, in those places, instead of electrodes, it is a substitute. You can use the electromagnetic sensor. So you are able to achieve the data acquisition in that hard surface stratum as well, where it has a high contact resistance. So cemented platform. Now we are choosing this platform. So the same, and one more second advantage is there. Even for electrodes, we need large space. But for sensor, even a small plot, you can able to do the groundwater investigation. So it is just about 5 meters space, and we are keeping at 1 meter interval. But you can have a question whether we can go at 0.5 meter or 0.25 meter. Yes, it is possible. It is feasible to do. So now we are starting with 1 meter interval just for our understanding. So it will be very simple and self-explanatory. So the first data acquisition is now happening. So Mr. Viraya is operating the equipment, ADMT 500 AX series. So first data is being acquired in this place. But there is one difference between using the electrode and sensor. So in electrode, always the data acquisition happens on the center portion, that is in the midpoint of the profile. That is either you keep at 10 meter spacing or 5 meter spacing. In the midpoint, you are going to get the data acquisition vertically down in the subsurface. But wherein the sensor, the data acquisition happens at the place where the sensor is placed. So this midpoint, say a sensor is about 18 centimeters in length. So the midpoint of the sensor is the data acquisition point. But it doesn't matter even the sensor because it is very short. So even up to half feet or 1 feet, it is a little bit disproportionate in the positioning. There is no problem. So so where you place the sensor, you can mark it with the chalk powder or spray marker. So this is the first observation point. So once it is done, then we are going to shift it to 1 meter ahead. Then we are going to shift 1 meter ahead. Like that, we are going to take 6 readings. So first position is 0, second position is 1 meter, third position is 2 meter, then fourth position is 3 meter, fifth position is 4 meter, and sixth position is 5 meter. So 0 to 5 meters, we are going. That is the zone for data acquisition. Here there is no fringe zone like in the data acquisition using the electrodes. So now the first data acquisition is first station is done. So we are confirming the data and it is stored. Now we will keep 1 meter ahead. So this is 1 meter. So you can have a question whether we can place a sensor like this or like this. It doesn't matter, but wherever you, for example, first you place like this, you continue in the same orientation. Don't change the orientation like this. If you are keeping like this, you continue for next consecutive readings. Or if you are keeping in this position, cross the position, then you keep it consecutively for consecutive stations also, you keep in the same way. So now we are kept in the previous reading towards north to south. So it is facing towards north. So we are keeping the same direction now, same position. So next second station, the data acquisition is now being progressing. So totally we have completed the 6 stations using the sensor, thanks to the sensor. So now, okay. So the 6th reading is, the data is progressing. It will complete in few seconds. So once it is done, we are going to repeat the same way of drawing the graph. So the graph, as we told earlier, it has classic, new version, and then graph 1 and graph 2, and then AI, artificial intelligence. Besides that, it is for the 2D, and then another one is for the 3D. So the same way we are going to develop the graph. So now the data acquisition is done. So now it is ready for drawing the graph. So what we will do, we will remove the cable first. Then we will go for the drawing the graph. By using the sensor, we have went up to 60 meters at 2 meter measurement interval, frequency interval. And now we are going for the draw option. See, the draw is turned gray to blue. So that means it's ready for drawing the graph. Now we go for the classic. Let us see the graph. So the graph is done. So once it is done, if you want, you can go for 3 dimension also. 3 dimension. So through dimension you can save it. Once it is saved, it can be stored in the file folder. Then we can close it. So once it is done, the same data, you can see the today's date, that is 19th November 2024. You open it, you can see all the files. So it is in blue color. So it is, again, you want to continue the same profile, you can do it. Otherwise you can just view the data and you can come back. So here you can see the blue color. Once you connect with the hotspot or Wi-Fi, then you can turn this blue color into gray color. That means this device is registered with a mobile number. So cloud based data storage system. So this blue color will turn into gray. That means the data is stored to the registered mobile number. So which can be used for even tomorrow this machine got crashed or data is completely full. So you need not worry about it. So the data is already stored in the cloud and you can use it any point of time for your future work. Thank you.
చూసాం కదండి మనము WTS వాళ్ళ జియోఫిజికల్ అసెస్మెంట్ ఎక్విప్మెంట్ ఏ విధంగా పనిచేస్తుంది ఏంటిది అని. ఇది ADMT 500 AX1D అనమాట ఇన్స్ట్రుమెంట్ పేరు. లిటిల్ ఫ్లవర్ కాలేజీలో మనము దీన్ని సర్వే చేసి ఏ విధంగా దీన్ని డేటా ఇంటర్ప్రిటేషన్ చేసాము, సర్వే డేటా క్యాప్చరింగ్, తర్వాత డేటా రికార్డింగ్ అనేది ఏ విధంగా చేసామో మనం చూసాము. దీన్ని మరింతగా ఇంకా వాడి హైదరాబాద్ నగరాన్ని మరి నీటికి పుష్కలంగా ఉండి తగిన ఇంకుడు గుంటలు, తర్వాత ఇంజెక్షన్ బోర్వెల్స్ వేసుకుని మనము హైదరాబాద్ నగరాన్ని నీటి సంరక్షితమైన నగరంగా మార్చాలని చెప్పి కోరుతున్నాము. DWS జియోఫిజికల్ సొల్యూషన్స్ అధికారులు మన అబ్దుల్ గారికి, మన మొహమ్మద్ ప్రభు అబ్దుల్ గారికి, తర్వాత ఏమో వాళ్ళ బృందం ఇక్కడ హైదరాబాద్ వాళ్ళకిను, తర్వాత సెల్వి సార్ అక్కడ జియాలజిస్ట్ వాళ్ళకి ఎంతో కృతజ్ఞతలు ఇక్కడికి వచ్చి మనకి డెమాన్స్ట్రేషన్ చేశారు. తర్వాత మా బృందంలో కూడా పనిచేసే శ్రీధర్ గారు, ఆ జియాలజిస్ట్ గారికి కూడా కృతజ్ఞతలు. ఆయన కూడా వచ్చి ఇన్స్ట్రుమెంట్ గురించి ఏ విధంగా ఉంది ఏంటా అని చెప్పి ఆయన కూడా అసోసియేట్గా మన దగ్గర వచ్చి చూశారు. తర్వాత మన కెమెరామెన్ ఖలీల్, వాళ్ళకు కూడా కృతజ్ఞతలు. లిటిల్ ఫ్లవర్ కాలేజ్ అధికారులు మన బ్రదర్ అరుణ్ ప్రకాష్ గారు, ఆయన కూడా మనకి ఇక్కడ అవకాశం ఇచ్చినందుకు ఎంతో సంతోషము. ధన్యవాదాలు.